Assalamu alaikum everyone. Today we have to start this chapter number 8, which is about the estimation of the manufacturing cost. Okay, so what is basically this manufacturing cost? It is you can see this cost as the running cost of any plant or the process to generate some product. Okay, so the units of this manufacturing cost, it would be the cost divided by time. So it can be in the form of dollars per month, dollars per year, or dollars per day. Okay, so it is amount of expenditure that you require to spend on the production of any product in terms of dollars per unit time. Okay, now let us see what are the different items that we need to consider for estimation of the manufacturing cost or the running cost of any process. Okay, now there are different cost heads in the manufacturing cost, which include the direct cost, fixed cost, and the general expenses. Now what is this direct cost? In this direct cost, it basically represent you the operational expenditure, which can vary with the production rate. Okay, so it depends on the demand and supply of the products. Okay, if the supply is high, you need to spend more cost, or if the demand is high, you need to generate more product, that will increase the direct cost. Also it depends like which raw material or the feedstock you are using in the process to generate some specific product. Okay, so that will come under the category for this direct cost. Okay, now the second thing that we can see here, it is the fixed cost, and it do not vary with the production rate. Okay, now the fixed cost, we will see that what are the different things we need to include in the fixed cost, but generally we can include the property taxes, insurance, and maybe the depreciation of the plant in the fixed cost. Okay, so even though the plant is running or not, this cost should be there, which you need to spend in 1 year or whatever the time you can specify. Okay, now number three category, it is about the journal expenses. Now it will include the cost associated with the management levels and administrative activities not directly related to the manufacturing process, and it can be called as the overhead burden. Okay, now in this kind of journal expenses, we can include the management cost. We can also have the sales department, so we have to bear the salaries of those personals. We can have like some kind of financing from the bank, so we have to pay pay the monthly like expenditure for the installments. Okay, and sometimes we have to like run the research labs that should be keep on running. Okay, so these are coming under the category for this journal expenses. Okay, now let us see some of the more details in terms of direct cost and what are the different heads that we need to include here. So the direct cost, it will include the raw material cost or the feedstock. So the cost of chemical feedstocks required by the process, flow rates obtained from the PFT. Okay, so you can have have the idea about the raw materials which you want to use for any process, and you can have this information about the flow rate of those raw materials from the PFT. Okay, then it will also include the waste treatment cost of the waste treatment to protect environment. So we can have maybe some specific waste treatment units in case of maybe if there is some liquid discharge from the plant, then you have to clean that water and then you can release it into the environment. And similarly, if there is some power plant, so we have to see what are the emissions, sulfur emissions or the carbon emissions. So we have to take care of the environment also then, and the equipment that we would require there, that would have some like waste treatment cost. Okay, so that comes into this category. Then we can have different types of utilities into the plant. It can be fuel, gas, oil, coal, electric power, steam, cooling water, process water, boiler feed water, instrument air, inert gas, refrigeration. Okay, so all of these are the utilities, and it depends like if the process is running, what is the input and the output requirement. So this can also vary with the product demand. Okay, and then we can have the operating labor, cost of the personals required for the plant operation. So we can have operating labor in the head for the direct cost. Similarly, we can have the direct supervisory and clerical labor. Okay, so some more domains of the labor, maintenance and the repairs, cost of labor and materials associated with the maintenance, so that is also the part of direct cost. operating supplies that will include the cost of miscellaneous supplies that support daily operation, not considered to be the raw material. Examples include chart paper, lubricants, miscellaneous chemicals, filters, respirators, and protective clothing for operators. Okay, so these are the other supplies that we need in any of the plant. Okay. Now let us see what we have. So also the laboratory charges and the patents and the royalties. These come under the category for the direct cost. In the indirect cost, we have to see what is the depreciation of the plant. Okay. Now, then we have to see what are the local taxes and the insurance. Then we have to see what are the plant overhead cost. Okay. So you can see some of the details about these specific heads and what are the terms that we need to include. Okay. And then we can have the journal expenses that include the administration cost, distribution and the selling cost, and research and development cost. Okay, so these are the different heads in which we can actually divide the manufacturing cost. It can be the direct cost, it can be the fixed cost, or it can be the journal expenses, and then we have to add up all of these things together to get the value for the manufacturing cost. Now let us see what is the equation that we can have for the cost of manufacturing. It can be represented as COM, and it is a combination of direct manufacturing cost, fixed manufacturing cost, and the journal expenses. As we discussed earlier, the cost of manufacturing can be determined when the following costs are known or can be estimated. So the cost of manufacturing itself, for the measurement of this cost of manufacturing, we should have the values of these five indicators, okay, or these five variables. So what is the first variable? Fixed capital investment. So it can be represented as FCI, and where we can get the value for FCI, it is equal to the CTM, which is the total module cost of the equipments or grassroots cost of the equipments. Okay. Then we should have the value for the cost of operating labor. So we have to see that how many personals we need to have in any of the plant to look after that plant. Okay. So we have to see cost of operating labor. Then we have to see the cost of utilities. Then we have to see the cost for the waste treatment. Then we need to see what is the cost for the raw material, and then we can actually add up all of these things together to estimate what is the value for the cost of manufacturing. Now let us see some of the tables and what are the different things that can be added up together to get the value for the manufacturing cost and the direct manufacturing cost and the fixed manufacturing cost and the journal expenses. Okay, so we can see this one. The first category, it is about the direct manufacturing cost. It is a combination of raw material, waste treatment, utilities, operating labor, direct supervisory and clerical labor, maintenance and repairs, operating supplies, laboratory charges, patents and royalties. Okay. Now, after each of these equipment or after each of this category, you would see the abbreviation: cost of raw material, CRM; waste treatment, CWT; utilities, cost for the UT. Okay. And operating labor, it can be represented by COL. And then to get the value for the direct supervisory and clerical labor, the range, it can vary from 0.1 to 0.25, which is a multiple of COL. So it is a function of operating labor, and the value that we can use in the textbook, it can be 0.18 multiplied by cost of operating labor. Then maintenance and the repairs, the average value for this one is 0.06, which is FCI, is the fixed capital investment. Okay, so that is equal to total module cost or the grassroots cost. Okay, and then we can have the operating supplies as a function of fixed capital investment as multiplied by 0.009. Similarly, the laboratory charges, we can have this equation: patents and royalties, it is the function of COM, which is the cost of manufacturing, and multiply by 0.03. Okay, now we have to add up all of these costs together to get the value for total manufacturing cost. Okay, so this is the equation that we have for the total manufacturing cost. And now here, if you see this one, 1.33, okay, COL, so 1.33 cost of operating labor. So you can see this one, one value for the COL here, then 1.18, you have to add this one, and then when you add this one, 0.015 with the OL, cost for the OL, so it will give you the total value of 1.33 cost of the operating labor. Okay, so this is how we can actually get the value for the total cost of direct manufacturing cost. Okay, so this is one of the equation. Now we have to see that what is the fixed manufacturing cost, and it includes the depreciation, local taxes and insurance, plant overhead cost, and here you would see what are the relevant equations. Okay, and then you can add up all of these equations together here to get the value for the total fixed manufacturing cost. Similarly, you can have the administration cost, distribution of and selling cost, research and development cost, and you would see the relevant equations on the right hand side that you can add together to get the value for the total journal manufacturing cost. Okay, so once you have the value for the total journal manufacturing cost, total fixed manufacturing cost, and the total direct manufacturing cost, you can add all of them together to get the final equation in this form. Okay, so this will represent you the total manufacturing cost of any process. Okay, now let us see some of the more equations. Actually, we are using the same equations. If you one equation is this one that represent you the total manufacturing cost. But if we rearrange this equation in the form of cost of manufacturing, okay, we can finally get this kind of equation, which is equal to 0.280 fixed capital cost, fixed capital investment 2.73, cost of the operating labor 1.23, in which you have the cost of the utilities, cost of waste treatment, and cost for the raw material. Okay, so this is one of the equation here, and this equation actually it includes the depreciation value of 10% of the fixed capital investment. Okay, so whatever the fixed capital investment is, the annual depreciation is taken as maybe 10%. Okay, so the equation that we get here to estimate the value for the cost of manufacturing, we can have this equation, and that includes the factor for the depreciation of 10% of the fixed capital investment. Okay, but if we do not have any depreciation value from our analysis, then we can convert this equation into the second form, COMD. So this represent cost of manufacturing without including the depreciation. Okay, so that includes the equation without including depreciation of the plant. Okay, so the new equation that we get here is in this form. Okay, so you have to see which equation is more relevant to your analysis. If you want to simply estimate the value for cost of manufacturing, you can directly use this equation. If you want to include the depreciation, if you don't want to include the depreciation, then you can go for the equation 8.2 to estimate the cost of manufacturing. Okay, now let us see what we have. Fixed capital investment. We have studied this thing earlier in the chapter number 7 in the form of total module cost or the grassroots cost, and CRM, which is the cost of the raw material, cost of the utilities, cost of waste treatment, cost of operating labor. We will see each of these categories separately in this chapter also. Okay, so let us see. Now let us solve this example, which is very simple. So let us see what we have here. The following cost information was obtained from a design for a 92,000 ton per year nitric acid plant. Okay, so there is a plant with the annual capacity of 92,000 ton per year. The fixed capital investment, it is given here, $11 million. Raw material cost, it is $7.95 million. Then we can have the waste treatment cost of maybe $1 million. Utilities, it is $0.356 million. Direct labor cost $0.3 million, and fixed cost, it is $1.5 million. Now we have to determine the manufacturing cost in dollars per year. So we have to see what is the total value for the manufacturing cost in dollars per year and dollars per ton of the nitric acid. Okay, so there are two variables that we need to calculate. First one, the manufacturing cost in terms of dollars per year, and then the manufacturing cost in terms of dollars per ton of the nitric acid. Secondly, the percentage of manufacturing cost resulting from each cost category given in the tables 8.1 and 2. For this one, we have to see that what is the percentage of the total manufacturing cost that is liable to these heads. Okay, so let us see how we can calculate these costs. Now here you have to use this equation. First of all, we have to calculate the cost of manufacturing, and D, it will represent you that we are ignoring the depreciation value. So the equation that we can actually use here, it will be in this form. Okay, cost of manufacturing 0.180 FCI which is the fixed capital investment. Then we can have 2.73 cost of labor, and then we can have these utilities, waste treatment, raw material. Okay, so we can use this equation to get the value for the cost of manufacturing. So this one, 0.180 fixed capital investment. So we have the value for the fixed capital investment. Then we can have 2.73 multiplied by cost of operating labor. So the operating labor, it is $300,000 per year. Okay, so we can have this value. Then we can have plus 1.23 in the bracket. We can have 3.5 $3,5600 dollars. Okay, so we can have this one as a utility cost. Then we have to include the waste treatment cost. Then we have to include the cost for the raw material. So all of this information, it is provided you in this table. Okay, so the total cost of manufacturing, it would be equal to $14.25 million per year. And then actually we can convert this cost into the dollars per ton, depending on the production. Okay, so the production is 92,000 tons per year, so we can divide this term with the annual production here to get the value in terms of dollars per ton. Okay, so that was the second part of the question. We have to calculate the value in terms of dollars per ton. Okay, so simply we can calculate this way. Now we have to find out the relationship of the manufacturing cost. So each of these costs we have to see, like how much is the percentage of direct manufacturing cost on the total cost, and then what is the percentage of the fixed manufacturing cost, and then we have to see what is the percentage of the general manufacturing expenses. Okay, so what we can do here, we have calculated this thing earlier. So the direct manufacturing cost, what is an equation to use to calculate the direct manufacturing cost? So we can see the equation to estimate the value for the direct manufacturing cost. So we can go back here and see what is the equation. Okay, so the total direct manufacturing cost, we have to include this equation, cost for the raw material, cost for the waste treatment, cost of the utilities, 1.33 multiplied by cost of the operating labor plus 0.03 cost of manufacturing, and then we can have the value for 0.069 for the fixed capital investment. Okay, so we have to use this equation to estimate the value for the total direct manufacturing cost. So the same thing we did here. Okay, so we have done this thing. What is this? This one, $7.95 million. So we have included the cost for the raw material. Then we actually include the cost for the waste treatment. Then we included the cost for the utilities. Then 1.33 multiplied by COL, cost of the operating labor. Then we can have 0.069 with the cost of manufacturing. So it is given here, cost of manufacturing or the fixed capital investment. And then we can have 0.03 with the cost of this one, cost of manufacturing. Okay, so that comes out to be so we can have this one, the cost of manufacturing, to be $14.25 million. So we can multiply this one here. Okay, so the total direct manufacturing cost, it comes out to be $10.89 million. Now we have to see what is the percentage of this direct manufacturing cost and what is the share of this manufacturing cost into the total cost. So you can take this one, $10.89 million. You can divide this one with the $14.25 million, multiply by 100 to get the percentage. So almost 76% of the manufacturing cost would be going into the total cost. Okay, then similarly we can estimate the value for the fixed manufacturing cost. Okay, so you have to see what is the relevant equation here. So this is an equation, so you have to include the cost of operating labor and the fixed capital investment. We are ignoring the part for the depreciation, it is not a part of your question. So simply we can have this one, 0.708, we can multiply this one with the cost of the operating labor. Then we can have the second, 0.068, we can multiply this one with the cost of or the fixed capital investment. Okay, so we have the value for the fixed manufacturing cost, and then we can divide this one, $0.96 million with the $14.25 million to get the value in terms of percentage. So 7% of the cost would be going into the head for manufacturing cost. Similarly, for the journal expenses, you can see this equation. What is this equation? Okay, so similarly you have the value for the cost of operating labor, you have the value for cost of fixed capital investment, and cost of manufacturing. So you can simply use in this equation one by one. This one is cost of operating labor. Then here you can have the fixed capital investment, and then you can have here the cost of manufacturing that we get here. Okay, so the total value comes out to be $2.43 million, and then you can actually divide this one $2.43 million with the $14.25 million to get the percentage of the journal expenses. Okay, so what we see here, maximum cost would be going into the direct manufacturing cost, then we have the higher value for the journal expenses, and then the least value would be the fixed manufacturing cost in terms of percentages. Okay. So this is a part for estimating the direct manufacturing cost, fixed manufacturing cost, and the journal expenses. Now let us see that how you can actually find out the number of operating labors, okay, and what is the requirement in the equation, and what are the key technical parameters that you need to consider. Okay, so this one, and O, I'll represent you the number of operators per shift. Okay, now in one day you can have 3 shifts, so this equation will give you the number of operators per shift. Okay, so whatever value you get here, you have to multiply this one with the 3, and then you have to see how many maybe the annual working hours for an industry, and then you can actually get the value for the cost for the operating labor. Okay, so NOL, number of operating labor, it would be a function of 6.29 plus 31.7 p square plus 0.23 and NP power 0.5. Now here the P represent, you can see that there could be two different types of processes. One process in which there is no solid handling, okay, and in one process you can have only the fluid handling. Okay, so if there is some processes in which you are dealing with the solids, then you can see what equation you can use. Okay, so this equation you can only use if your plant includes two types of particulate processing steps. Okay, so if it is having like the two particulate processing steps, or the solid treatment step, then you can use. Okay, if the value for the particulate processing steps it is greater than 2, then you cannot use this equation. Okay, so particulate processing steps, if it is less than 2, you can use this one, otherwise you cannot use this one. Okay, so we will see this one in the example also. NNP, so that includes the non-particulate processing steps: compression, heating, cooling, mixing, separation, and reaction. Okay, now you have to see that how many number of equipments are in your plant, and how many compressors are there, towers are there, reactors, heaters, and exchangers, and then you have to count down their number. Okay, so whatever the value for the number comes out, you have to put in this equation to get the value for number of operating labor. Okay, now when you calculate N and P, you have to only consider these equipments. Okay, if some other equipment is coming, you don't need to consider. Okay, so let us see how we can actually solve this one. Now here is some of the calculation of how many annual working hours for any of the operators. So usually 49 weeks per year it is the required time, and there are 5 shifts per week. Okay, so the total number of shifts that an operator can have in 1 year, it is 245. Then we have to see that how many number of shifts are there in 1 year, so you can simply do the calculation. So there will be 1095 shifts per year, and then you can see that how many operators would be required for each shift. Okay, so you can you can have this equation 1095 shifts per year, and then you can see this one, how many shifts would be required in one operating year. So you can have the value for the number of operators that you need at one time to operate the plant. Okay, now the hourly rate, you can get this value from the literature. So in your book, the hourly rate is given as $28.64, and for the annual working hours, which is given in your book, it is 2080, but it can vary depending on the plant and the location of the plant and the failures in the plant. Okay, so in your book it is given as 2080 hours, and against these 2080 hours you can have the value for the cost $59,580 for the one like the operator per year. Okay, so $59,580 for one operator in 1 year is the cost that you required for the operating labor. Okay, Now let us solve one of the example, which is very simple. Estimate the operating labor rate requirement and cost for the toluene hydrodealkylation facility in the figure 1.3 and 1.5. Okay, from the PFT in the figure 1.5, the number and types of equipments are determined using equation 8.4, and estimate of the number of operators required per shift is made. This information is shown in the table E8.2. Okay, so what you can do here, you can go to the book, to the textbook, and see this figure 1.5, and there you should count that how many compressors are there, how many heat exchangers are there, how many heaters, furnaces are there, pumps, reactors, towers, and vessels. So you can count down their number from the process flow diagram, and then you have to see that which particular equipment you have to count for doing the analysis. Okay, so if you look at this equation, N and P, it represent you the non-particulate processing steps, in which you have to see how many compressors, towers, reactors, heaters, and exchanges are required. Okay, so you can see this one. You first make the list of all the equipments that you have in the plant, and then you would see that, okay, so this pump, it is not a part of equation, so you can ignore the pump part here. Similarly, the vessels should be removed from the equation. Okay, so you can remove the vessels. Okay, so then you have to add up all the equipments that comes under the category for NNP, and the number come out to be 11. Okay, so once you have this number, you can use this equation again. So NNP, its value is 11, and P, basically we are dealing with the non-particular processing plant, right? So there is no solid handling system into the plant, so the value for P, it will be 0. Okay, so the equation that you have to use here, it is 6.29, then you can have 0 plus 0.23, again this one, and NNP, number of non-processing units, it will be 11. Simply you can solve this equation to get the value for the number of operating labors, that comes out to be 2.97. Okay, now once you have the value for the 2.97, then this is the number of labors that you required in one shift. So once you have this number of operators per shift, you have to multiply this number with the operating labor, which is 4.5, which is required to provide this much number of shifts in 1 year, to get the value of the actual labor requirement. Okay, so you can multiply 2.97 with 4.5, which comes out to be 13.4, and when you round up, it can be nearly equal to 14 operators. So you can multiply 14 with the amount of salary for one person per year. So that is here 59,580. That comes out to be $834,100 per year. Okay, so this is according to the labor cost for the year 2010. Okay, but this value, it can change with respect to the region and with the type of plant the operator is working on. Okay, so you can play with the different things. Okay, sometimes the number of shifts per week, it can vary, or maybe the number of shifts per day, it can vary. So ultimately these numbers can change. So first of all, you have to find out the number of operators that can be required to match this number of shifts. Okay, then once you have this number, you can use this equation to get the value of number of operating labor, and then you can multiply these two numbers together to get the actual number of operating labor. Okay, so this is all for today, and please let me know if you don't understand anything. Thank you.